Welcome dear students, this is your science class and today we are going to study about neutralization reaction, the formation of salts in this part of our chapter, acids, bases and salts. So the topics which we are going to study today are neutralization, how salts are formed during neutralization reaction. We'll see an activity which will show neutralization reaction. We will study about neutral, acidic and basic salts, and at the last we will study how neutralization is important in our daily life. When an acid solution is mixed with a basic solution in a suitable amount, their properties change. The acid and the base, they react with each other and their properties or their effects get neutralized. And what will be the result? As a result of their reaction, a totally new substance is formed and this new substance is called salt. And during this process, heat is also evolved. So to write it in the form of an reaction, you can write it as acid plus base will form salt, water along with the evolution of heat. Let's take the example of an acid and a base reaction. Here HCl, hydrochloric acid, is reacting with sodium hydroxide, NaOH. And as I have said, during this reaction, neutralization reaction between an acid and a base, a salt will be formed. So the product of the reaction between HCl and NaOH is NaCl, which is sodium chloride. And this sodium chloride is a salt. With this sodium chloride, water will be formed along with the evolution of heat. So we can say that the reaction between the acid and the base is called the neutralization reaction, in which a salt is formed and heat is released. Or in other words, we can define neutralization as the reaction between an acid and a base in which they neutralize each other's effect, and this is called neutralization reaction. So now we have learned that when an acid is mixed with a base, both of them react to form water and a new compound which is called salt along with the evolution of heat, and this process is called neutralization. The salt that we add to our food is sodium chloride and it is formed by the neutralization reaction between hydrochloric acid and sodium hydroxide. As I have shown you the reaction before, this is HCl, this is hydrochloric acid. It reacts with sodium hydroxide, NaOH. Sodium hydroxide, and both of them react to form a new compound NaCl. This is sodium chloride along with water and heat. Heat is evolved during this process. The hydrochloric acid is a strong acid. This HCl is a strong acid, and as we have read earlier that acids are corrosive in nature. This strong acid can even burn the skin. This is so harsh. And this sodium hydroxide, this is again a strong base. This is also harsh on skin. But when these two strong acid and bases react together, they form a new compound which is sodium chloride, and this sodium chloride form is the result of the neutralization reaction between HCl and NaOH, and this sodium chloride is perfectly safe to eat. Why? Because both of them have neutralized the acidic as well as the basic effect of each other, and they have formed a totally new compound which is called sodium chloride, which is a common salt. Sodium chloride is referred to as the common salt. So we have seen that salts are the product of the reaction between an acid and a base. So we can say that the reaction between an acid and a base result into the formation of water and a compound which is called salt. Let's perform an activity to show neutralization reaction. And before starting this activity, I would like you all to recall what is neutralization. It is a reaction between an acid and a base in which the acidic as well as the basic effect of acids and bases are neutralized. And one more thing I want you to recall is phenolphthalein. If you can remember, phenolphthalein is a synthetic indicator, an indicator for acids and bases, and when phenolphthalein is added to acid it becomes colorless, and when it is added to a base it shows a pink color. Okay, let's start our activity. The aim of our activity is to demonstrate neutralization reaction. Let's collect all the things which we need to perform this activity. We will need dilute hydrochloric acid, that is HCl, which is an acid, then phenolphthalein, which is a synthetic indicator, sodium hydroxide NaOH, which is a base, a conical flask, and a dropper. So first we have to take some amount of HCl in a conical flask. And to this we have to add a few drops of phenolphthalein solution and observe the reaction between the two and tell the color which you will observe. What color should be there? On adding phenolphthalein to hydrochloric acid, will there be any change in the color? No color change will be seen. Why? Because phenolphthalein is colorless with acids. Now use a dropper to add sodium hydroxide, that too drop by drop, and keep stirring and find out if there is any change. On adding sodium hydroxide, which is a base, the solution will become pink. Why? Because phenolphthalein is already present in the solution and it shows a pink color with a base. Now add one more drop of dilute hydrochloric acid to this solution where HCl is present, phenolphthalein is present, and NaOH is present. To this solution you have again added a drop of HCl, an extra drop of HCl. So what will happen? Will there be any change in color? You will observe that the pink color which was produced or which was seen due to the addition of sodium hydroxide, a base, it has gone. The solution has again become colorless, and if you touch the flask you will feel that it has become warm. Why all these things has happened? They are happening because phenolphthalein is colorless. It becomes colorless when it is added to acid, and when it is added to a base it shows a pink color. So till step 2 it is clear. Now what has happened in step 3 that the pink color has got vanished? On adding sodium hydroxide, the solution has become basic and it is showing the pink color. But when one more drop of acid is added to the solution, the acid and the base has neutralized each other's effect. And I have told you earlier that a neutral substance will not show any color change with any indicator. So this is showing that the solution has become neutral in this third case. So we can conclude from this activity that when an acidic solution is mixed with a basic solution, both of them neutralize each other's effect. And one more thing is proved here, that when you have touched the conical flask, you felt that it has become warm now. So as the conical flask has become warm, it shows that the neutralization reaction is accompanied by the evolution of heat. So in this whole activity, we have proved that when an acid reacts with a base, both of them neutralize each other's effect, forming a neutral substance which is salt, and heat is also evolved during this process. The salts formed after neutralization reaction will not always be neutral in nature. They can be neutral, acidic, or basic. Let's see how they become neutral, acidic, or basic. When the acid is stronger, the salt is acidic. The salt which is formed by the neutralization of a strong acid by a weak base will give an acidic salt. For example, HCl, hydrochloric acid. This is a strong acid. This is strong, and it reacts with ammonium hydroxide, which is a weak base. This is a weak base. So the salt formed after their reaction, after their neutralization, will be acidic in nature, and the salt formed is ammonium chloride, and this is acidic in nature. And if you want to test whether the salt form is acidic or basic, you can use any indicator. You can use litmus paper, and what will be the result? It will turn blue litmus red, which confirms that the salt which is formed by the reaction between strong acid and a weak base is a acidic salt. Now second is the case when the base is stronger and the salt will be the basic one. When the base is stronger, means strong base and weak acid will form a basic salt. They will form a basic salt. For example, NaOH, that is sodium hydroxide. Sodium hydroxide, which is a strong base. It reacts with acetic acid. Acetic acid is a weak acid. It is a weak acid. And the reaction between sodium hydroxide and acetic acid will form sodium acetate. Sodium acetate, and the sodium acetate will be basic in nature. And if you test it using litmus paper, what will happen? It will turn red litmus paper blue, which is an indication or confirmation that the salt formed by the reaction between sodium hydroxide, which is a strong base, and acetic acid, which is a weak acid, is basic in nature. Now third category is when both acid and the base are strong, means strong acid plus strong base. They will form a neutral salt. For example, strong acid like HCl. It reacts with a strong base like NaOH and forms a salt NaCl, which is neutral, and it is our common salt. So the salt formed by the reaction between a strong acid and a weak base will be acidic. The salt formed by the reaction between a strong base and a weak acid will be basic, and the salt formed by the reaction between strong acid and strong base will be neutral in nature. Neutralization of soil is necessary to promote plant growth. When excess chemical fertilizers are used in farming, the soil becomes acidic. And to neutralize this acidic effect, farmers add bases like quicklime, which is calcium oxide, and slaked lime, which is calcium hydroxide, to the soil to neutralize their acidic effect. Similarly, basic or alkaline soil is also not good for many types of the plants, and to neutralize this alkalinity of the soil, farmers add some organic matter to the soil. This releases acids which neutralize the soil, and sometimes calcium sulfate and sulfur is also used for the neutralization of the basic soil. The gastric juices present in our stomach contain hydrochloric acid, and this acid helps in the digestion of food, and it also kills the harmful bacteria. But sometimes an excess of hydrochloric acid can cause discomfort and a burning feeling. This state is called indigestion or acidity. And for this, our doctors prescribe us with some tablets which are antacids. These antacids are generally MOM, which we have talked about it earlier, milk of magnesia. The chemical formula for it is magnesium hydroxide, and they are sodium bicarbonate. And both of them are basic in nature, and they are used to neutralize the acidic effect of the excessive hydrochloric acid. So they neutralize the excess hydrochloric acid in the stomach and relieve the discomfort that we feel. When an ant bites, we feel pain, and the area may become itchy. The area also becomes red and inflamed. So this happens due to the presence of an acid in the ant bite, which is formic acid, and its acidic effect can be neutralized by a base. Therefore, immediately that part is rubbed with a base like moist baking soda which is sodium bicarbonate, baking soda, or we can use calamine solution also, which is zinc oxide, and both of them are basic in nature, and therefore they will neutralize the acidic effect of this formic acid. Now this was the case of ant bite. In case of wasp sting, it is basic in nature, and therefore we will need an acid to neutralize its basic effect. Therefore, for wasp sting, vinegar is used. What is used? Vinegar. Vinegar is used in case of wasp sting. Why? Because it will neutralize the basic effect of this sting, being acidic in nature. Vinegar is having acidic acid, and this acidic acid will neutralize the basic effect of this wasp sting and give you relief. Many factory wastes are acidic in nature, and these effluents or the waste released from the factories, they can harm the fish and the other aquatic life if they are allowed to flow into water bodies without being treated. Therefore, it is needed to treat such waste, and they should be neutralized by adding basic substances before they are let into the water bodies. Acid rain. Acid rain is a rain or any form of precipitation which is acidic. And why is it acidic? This is acidic due to the presence of sulfuric acid or nitric acids. From where do they get these sulfuric and nitric acid? They are formed due to the reaction of sulfur dioxide and nitrogen oxides which are present in the polluted air, and these two react with water and form these harmful acids. These acids rain can damage buildings and statues because these are made up of limestone, marble and plaster. It means they are made up of calcium carbonate, and calcium carbonate is basic substance. So this is neutralized by the acid rain, which are having acids in them. These structures decay and they get coated with a black substance that contains gypsum. And how gypsum is formed? It is formed when sulfuric acid present in the acid rain reacts with calcium carbonate, which is a base, and thereby neutralizing each other's effect, and they form a black layer over the building. As you can see from the picture, this is the picture of Taj Mahal, and here in this picture it is clear how it was looking before and how it is looking now. Because of the acid rain, it has got some blackening over its surface. It has become dark now. So in this way we have finished our chapter. We have learned about acids, bases and salts. We have learned about what is pH, what are the indicators. We have learned about neutralization and what are the effects of neutralization in our daily life. Hope you all have understood it. Thank you.